Alright, this is the Unit 11 exam review. This is over sample space and probability. So sample space is the list of all possible outcomes. So we made a tree diagram to kind of show sample spaces and probability. And we show probability two ways, but basically what probability is showing, if we write it like a fraction, is the ways an event could occur. We write it like a ratio or a fraction over the total possible outcomes. Okay, so we could write it like a ratio or outcomes, or we could write it like a percentage. So to demonstrate these two things, I'm going to work a problem for you. Alright, if you flip a coin twice, what is the probability of flipping a heads at least once? Okay, so right off the bat, almost every student, without having to think too much about it, the common sense answer would be, okay, well, 1/2 to get heads, right? Wrong. It's not the right answer. I'm going to show you why. First, to do this, we need to create a sample space where we list all the possible outcomes. Okay, we're going to do that with the tree diagram, which is how we organize that. So, if we flip the coin one time, on that first flip, we can flip heads or we could flip tails. Okay, now, when we flip a second time, there are some outcomes that are different. Now, if I flip heads the first time, I could flip heads or tails the second time. Or if I flip tails the first time, then I could still flip heads or tails the second time. Okay, so there are 4 possible, I guess, outcomes from this. So you could flip heads and heads. So that would be a heads. You could flip heads, tails. You could flip tails, heads. Or you could flip a tails and then a tails. Okay, so there are 4 possible outcomes. This is the first one, second one, okay, third possible outcome, and the 4th possible outcome. Okay, so this is our sample space. This is how we construct a sample space. We have all possible outcomes. There are 4 here. Now let's talk about probability. So the probability of flipping heads at least one time. Okay, so let's look at this one. Did we flip heads at least once? Yes, we did. So we can count that. Okay, do we flip heads at least once here? Yeah, we flipped it on the first flip. Okay, what about over here? Yep, we flipped heads on the second flip. Here, we did not flip heads at least one time. No heads. So I'm going to cross that one out. Okay, so to make my probability, the denominator is going to be the total possible outcomes. So there are 4 possible outcomes. The numerator will be the possible outcomes that we're looking to find the probability of. In this case, there are 3 possible outcomes that have heads at least once. So I could put 3 right here. So that's my answer, my probability. 3 out of 4 flips, okay, are going to be heads. Now, if I were to convert this into a percentage, there are 2 ways to do that. Okay, the shortcut or the quick way is percent actually means parts per 100 per 100. That cent right there means 100. Think of cents in a dollar. Think about century. There are 100 cents in a dollar. There's 100 years in a century. So cent means 100. Per means part. Okay, so parts of 100. So if I can get the denominator to equal 100, whatever the numerator is, that will be my percent. So in this case, if I multiply the denominator by 4 by 25, I get 100. So the equivalent fraction, multiply this times 25, and I get 75. And so that is actually 75 parts per 100, or 75%. Okay. The other way to get a percent is to do a division problem, where we take the top dog, put it in the house. So we're going to take 3, put it in the house, put 4 on the outside, and we're going to divide. Now 4 will not go into 3, so I'm going to put a 0 there. And then we do the dot dot 0, dot dot 0. Okay, 4 will go into 30. It will go 7 times. 7 times 4 is 28, and I end up with a 2 left over. So I just add another 0 and drop it. And 4 will go into 20 evenly 5 times. 5 times 4 is 20. A remainder of 0. So this is my decimal. And if I'm going from a decimal to a percent, I use this right here. Okay, and I'm going from a decimal to a percent, so I start on this side. Then all I have to do is just move that decimal. The DP tells me what direction to move the decimal. If I'm going from percent to decimal, then I would be moving this way. Okay, but I'm not doing that. So I take 0 and 75 hundredths and move the decimal 2 spots. So I go 1, 2. Now a new decimal place goes right here. So that equals 75%. Okay. Yeah, there we go. Okay. So either way, either method I use, I get 75%. So 75% of the time, if I flip a coin twice, I will get at least heads one time. Okay, this leads us to our last problem. If you flip a coin twice, what is the probability of not flipping heads at least once? Okay, so this is kind of the opposite of what the previous question asked. The previous question asked, what's the probability of flipping heads at least once? This is what's the probability of not. So this is a key word, not flipping heads at least once. Okay, so this is pretty straightforward. If you just look at our tree diagram, there's only one option that doesn't flip heads at least once, and it's this option. So really quickly, we could say that's 1/4 or 25%. Okay, now that part's not hard. There's a 1/4 or 25% chance that we do not flip heads at least once, because only this one. But you may see an answer choice that's a little bit different. So what we can do is we can find the probability of flipping heads at least once and subtract that away from 1, and that will tell us the probability of not flipping heads at least once. So you may see it written a different way like this. So I have 1, and the probability of flipping heads at least once was 3/4. We determined that in the previous problem. And so if I subtract that away from 1, I'm left with 1/4. So it's a 1/4 probability of not flipping heads at least once if I flip 2 times. Okay, another way to look at that is to say, okay, I take 100% and I subtract away the probability of flipping heads at least once, which was 75%. And if I subtract that away, I'm left with the probability of not flipping heads at least once. So that would still be 25%. Okay, so either way, I'm still getting the same answer. But what you may see as an answer choice on the test is this. Okay, and this is the probability of everything represented by 1, and I'm subtracting away the probability of at least 1 head. Okay, so that's that, and I subtracted away from the probability of everything happening, and I'm left with the probability of not any heads in 2 flips. Okay, and this is not any heads. So that's that.